Here we go, kids. We are starting lesson 1-2, lines and angles. All right, we are measuring segments and measuring angles in 1-2. This isn't super critical that you write down, but basically there's units that we call standard units, and that would be inches, feet, and miles. Metric, it's millimeters, meters, and kilometers. That's okay. Now, we like to accentuate the positive. Distances are never negative. Crazy things happen. So remember, this takes us back to an idea way back in possibly algebra class where you talked about absolute values. So remember that an absolute value is like something minus something, right? And then we take the absolute value of it so that it's never negative. Right? It can be 0, but it can't be a negative number. And the rest of the time now I'm going to be talking about angles. After this quick little example, you almost don't need to copy this example down, except for the fact that I use absolute value. So you may want to remind yourself of what that means. How far is it from A to C? What is the distance? Now the distance from A to C, we write as, notice the way I wrote it, right? Just AC. Notice there's no bar on top. Now, where is A? Where is C? Well, A is at 2, right? And C is at 4. So what is 2 minus 4? That's -2. And what is the absolute value of -2? Now, we don't know the units in this case. The units are stripped out. So we would just say it's 2 units. Say that again?
It says centimeters at the end of the line.
Oh, it does say centimeters.
Yes.
Thank you. Okay. The rest of the time I'm going to be talking about measuring angles. Measuring angles, degrees is how we measure them. Now you would think there's only one way to do that. There's actually, I know of 2 other methods to measure angles other than degrees. But right now you only know degrees. You'll only need degrees during this particular course. 0 to 180. Now be careful, if you flip all the way around, you get 360. That's a full circle. But the angle measurement will always be positive. And it will always be between 0 and 180. You won't get measurements above that. Keep in mind there's something called counterclockwise. Sorry, I meant to write clockwise there, not counter. As the clock turns, and then counterclockwise. Okay, which way is clockwise? Well, clockwise is this direction. Counterclockwise is that one. Higher mathematics says one of those is positive, one of those is negative. We're not going to worry about that. It's all going to be positive for you. Okay? No matter which direction you go. All right, the measure of angle ABC. Notice how we use a little m in front of the angle to indicate that we are doing a measurement of the angle. All right. So here goes an angle measurement. Let's say I'm going from A. You're measuring the angle ABC. So the angle is this one here. Ugh. Okay. So where is A? A is 50 degrees this way. This piece here is 30 degrees. So I'm going to take 50 plus 30, and that's going to give me 80 degrees. Notice they're kind of going opposite directions. A is going, you can think of, I suppose you could go starting at A down and then, yes, but again, we're not going to say negative 80 degrees, we're just going to say it's a positive 80. Okay. Hopefully this next piece now is something which is a bit of a review, that these words are not new words in vocabulary, right? What does it mean to be an acute angle, a right angle, an obtuse angle, and a straight angle? Do you know these things? Acute, less than? 90. Right?
90.
Yeah. More? Obtuse is more than 90? Or actually, and less than?
And less than 180.
Yeah. And what about a straight angle?
180.
180 precisely. Okay, and I'm going to go back to the acute and say more than 0 also. So an acute is obviously between 0 and 90, obtuse 90 to 180. This next thing is going to be completely new to you, and it might even give you a few gray hairs. What is the part of a degree? Okay, well, one rotation around a circle is 360 degrees. So one rotation is 360. That's not part of a degree, though. Let's take 1 degree. So imagine, if you will, 360 degrees going all the way around. Yes? But what if I just took just a little sliver of this? 1 degree. Right? We can cut up a degree into smaller parts. And what we get is minutes. Would you like to guess a number as to how many minutes there are in a degree? What number do you associate with minutes? 60. Yeah. Yeah. 60 minutes in 1 degree. So that means that little sliver of the pie can be cut up into 60 smaller pieces. And you may be asking yourself, why would anyone ever want to do that? And there's a good answer to that question, okay? And then 1 minute, so if I zoom into this region and I cut up each of those tiny little minutes, I can cut it up into another, what we call seconds, and each one of them is 60. Okay, so just like 60 seconds or in a minute on a clock, when we measure angles, and we want to be super, 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 super precise, then we go to minutes and seconds. By the way, degrees, we do a little circle above it, right? Minutes, it's like a little apostrophe, and then seconds, we use a double apostrophe. All right? And now, let's find, I think it's here. Nope, here. There we go. All right, here we are. All right, do you recognize this place?
No.
So if I put a spot down, let's see if it should put a, all right, you can't see that in the back. It says 45, 34, 50 degrees. Sorry, 45 degrees, 34 minutes and 50 seconds north. So if I'm measuring north, which is up and down, that tells me I'm 45 degrees north of the equator, 34 minutes and 50 seconds. Yes? I'm going to back that up. I'm just going to come down here to the entrance. Watch those seconds. Okay, now I'm at 45, 34, 49. Okay, so I'm down a second just by going from the middle of our building out to the entrance. It's quite a distance, yes? So when we're measuring large things like the Earth, we have to be really precise in terms of our measurements. And I could also go east and west. So if I went out to this side, I'm at 54 seconds. And if I went to the other side of the building, I'm at 42 seconds. So that's quite a number of seconds to go horizontally across that building. Okay? Your problems are not going to be of that nature. Your problems are going to be like subtracting things. So ready? Here now we're going to do a calculation. Go ahead and sketch something like this with A, B, C, D in your notes. And we'll get 90 minutes. So ABD, this angle here, is a 90-degree angle. ABC is 74 degrees, 21 minutes, 10 seconds. Our job is to find out what is the remainder, CBD. How much is left over? Can you tell me what do I have to do with these numbers, 90 and 74, 21, 10? If 90 is the whole and 74, 21, 10 is the part, subtract? Does that make sense? I'm going to take this whole piece minus this piece. So I'm going to subtract these two. To do that, I'm just going to work over here a little bit separately. And I'm going to line them up, much like I did back in the days when I just learned how to subtract things. And now, I notice I cannot subtract 10 from nothing. So guess what I have to do with 90? I need a number here and here. Anybody remember what we have to do? What do we call that? Starts with a B. I have to borrow. Okay, so I'm going to call this 89. I'm going to borrow a degree. Right? 1 degree is how many minutes? 60. Is that sufficient? Well, no, I've got seconds. I got to get here. So I've got to borrow from the 60, and that becomes a 59. Okay, so now I can subtract. 60 seconds minus 10 seconds is 50. 59 minus 21 is 38. 84, 15. So 15 degrees, 38 minutes, 50 seconds. All right. This is a word I think I already said. Congruent. What does congruent mean? It means to have the same size and the same shape. Yes? The symbol looks like an equal sign, but on top of the equal sign we have a little tilde. So, for example, I might have angle MNO is congruent to angle STU. And what that means is those two angles have the same size and the same measurement. And that might seem a little odd to you, like how could you have a different size? Look at the perimeter of these two, yes? Let's pretend this is 1 by 8. You don't need to copy this down, just look at it. This is a 1 by 8 and a 2 by 4, yes? Do they have the same area? And we would say yes. Do they have the same perimeter? No. So these two are not congruent even though they have equivalent perimeters, right? Okay, so we can have, in certain instances, we can have the same size but a different shape. Or we could have the same shape but a different size. Okay? Congruent means both are together. When you mark an angle, they typically do this with hash marks. Okay, they put a little line through. And the hash marks show us, in this case, we don't need to copy all these down, right? But AB is congruent to XZ. And likewise, CB is congruent to ZY. Just count the hash marks, match them up with the equivalent hash marks on the other side. Okay? Now, angles, be careful. I'm not going to write it. You don't need to copy this down. I just want to highlight something with angles. Angle T, yes, angle T and angle P, since they both have one little, they'll be congruent, right? So likewise, angle E and angle A. Notice how I marked angle D and L, slightly different. Yes? And oddly enough, in one occasion, the book, it rarely does this, but occasionally, instead of using a hash mark, it puts a little circle. I have no idea why it does it. To me, that's confusing. But in this case, that circle would mean TD is congruent to PL. Okay? So angles are marked a little bit differently than sides. Okay. I have two. Let me start with the easier problem. Angle cool is obtuse. All right, and I'm going to say it's 2x plus 12. Yeah, whatever. Yeah? Now look at the fancy word I used there. It said, angle cool is obtuse. What are the restrictions? Okay? I should have said, what are the restrictions on x? Okay? Let me add that to that. What are the restrictions on x? Can x be any number it wants? Well, here's a hint. What do we know about obtuse angles? It's got to be above, say it again,
90.
above 90 and
Less than 180.
less than 180. So let's set, ready? I need to do two problems. There's one problem I need to do. 2x plus 12 is less than 180. The other problem I need to say is that 90 is less than 2x plus 12. Oh, some algebra just crept into the room. Can we solve these two inequalities? Can we get x by itself? Do you remember? Subtract 12. 168. Subtract 12. Subtract 12. 78. How do I get rid of the 2? So x has to be less than 84. And then here, x has to be bigger than 39. All right? So what are the restrictions on x? X must be less than 84 and greater than 39. Okay. That was the easier of the three problems. Oh. I think we better do this one next. Okay, ready? We're going to draw a clock. You don't need to put all the times down. Please put at least these times down for me. 9, 12, 3, 6, and get the 5 on your clock somewhere. Yeah? Get those down. And then put the little hand. The little hand is at 5. The big hand is at 3. And the question is, what is the time? What is the angle measurement between those two? All right. Fact number 1, 360 degrees is a full circle, right? Could somebody tell me, based on that fact, how many degrees, raise your hand, if you know from 12 to 1, 1 to 2, how many degrees are there in each little hour? Just once you get that number in your head, just like, hopefully your brain said, there's 360 degrees, there's 12 hours on a clock face. So the answer is 30. Okay. Therefore, I have how many degrees from 3 to 5? Okay, so far I've got 30 plus 30. The temptation is to say 60 degrees and you're done, right? Does anybody know why the answer is not 60? Yes?
Because it's 5:15 o'clock.
It's not 5 o'clock, right? The hour hand has moved a little bit. How far has the hour hand moved? That's our last piece of the puzzle. Okay? I need to figure out this little bit right here. How much is that? Okay, well, so I'm going to say 30 plus 30 plus something. I now need to figure out that portion. Okay, ready? Back to the clock. The minute hand has moved this much of the circle. Yes? How much of the circle is that? Well, you can see it's not half, because half would be to 6. It's actually 1/4 of the way. Yes? So I'm going to take 1/4 times how much of this has the minute hand has the hour hand moved? Well, the hour hand has moved precisely 1/4 of the way. How do I know that? Because the minute hand moved 1/4 of the way, right? So as the hour hand moves from the 5 to the 6, it's going to move 1/4 of the way. So 1/4 times, how many degrees are there? 30. So 7.5. All right.